Hello, today we're going to teach you how to solve permutation. But before that, let's have to define it first. Permutation is an arrangement of k objects taken from a set of n different objects where the order of arrangement is important. And there are three formulas involved in solving permutation. These are this. First is P of n and k is equals to n factorial over n minus k factorial. The second one, P of n and n equals n factorial over n minus n factorial equals n factorial over 0 factorial equals n factorial. And the third one is this. P of n and k equals n factorial over n1 factorial times n2 factorial until nk factorial. So let's now try to solve problem with the first formula. Suppose the given is this. Find out the number of ways in which 4 girls can form a group of 15 in total to be lined up for a clique. So what we're going to do first is that we're going to find the value of n in the given problem. Our n there is 15. 15 because 15 is the total number of objects. K is equals to 4. Because as what we know, K is the number of objects taken. So now, let's going to solve the problem. P of n k equals n factorial over n minus k factorial. So, in solving this, instead of putting n, we need to put the value of n. The value of n there is 15 factorial over 15 minus 4. 4 because the value of k there is 4 factorial. 15 factorial is equivalent to 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 and times 1 over 15 minus 4 is 11 factorial. So now, let's just copy this. Over 11 factorial. 11 factorial is equivalent to 11 times 10 times 9 times 8 till 1. As we can see, there are numbers on the numerator which are the same in the denominator. So, as usual, we're going to cancel those numbers. So there are only 4 numbers left. 15, 14, 13, 12. Yes, that's it. Over 1. 15 times 14 times 13 times 12 is equals to 32,760. The final answer. Or there are 32,760 number of ways in which 4 girls can form a group of 15 in total to be lined up for a clique. So let's proceed to the other formula, the second one. We're going to use this formula. And suppose the problem is this. Given a word maths, find the number of possible arrangement of its letters. So as we can see, the word maths has 5 letters. Yes, 5 letters. And there are no letters which are repeating. So what we're going to do is to find the value of n and nothing else. So how many letters does math have? There are 5 letters. 2, 4, 5. And our n would be 5, of course, because as usual, n is the total number of objects. So now let's going to solve this using the second formula. P of n and n is equals to n factorial over n minus n factorial equals n factorial is n, there is 5, so we're going to replace letter n into its value. So 5 factorial over five minus 5 factorial. Five factorial is equivalent to 120. 5 times 4 times 3 times 2 times 1. just like what I did in the previous example. So we just directly get the answer of 5 factorial, which is 120. 120 over 5 minus 5 is 0 factorial. So now, according to the book, or according to mathematics, any 0 factorial is equivalent to 1. So it would look like this: 120 over 1. So the answer is 120 itself. So there are 120 letters. There are 120 number of possible arrangement of its letters. Now, let's go to the third formula. This. And suppose the problem looks like this. How many ways can we arrange the letters in the word lollipop? So as we notice, the word lollipop has letters which are repeating. So before that, let's find first the value of n. Our n there is 2, 4, 6, 8. 8 because there are 8 letters involved in the word lollipop. And as I said, there are letters which are repeating. So we need to consider those letters. Let's go first with letter L. How many times did letter L repeat? 3. So we're going to set 3 in letter L. The other one is O. O repeats 2 times, so 2. I is not repeating, so let's just not include it. P is repeating 2 times, just like with letter O. So P equals 2. Now, we're going to use the formula P of n k equals n factorial over n1 factorial, n2 factorial until nk factorial. So just like the previous example, instead of putting n, we're going to put or place it into its value, which is 8. So this would look like 8 factorial over N1 is the first letter which are repeating. So the first letter is L. So we're going to put the 3 factorial. The second letter is O, which is equivalent to 2. 2 factorial. P is also 2. 2 factorial. So 8 factorial is equivalent to 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. And 2 factorial is the same as 2 times 1. So what we're going to do is to cancel these numbers. Here. And the remaining number is 8 times 7 times 6 times 5 times 4 over 2 times, let's just going to multiply it directly. 2 times 1 is 2 and 2 times 1 is 2, so 2 times 2 is equals 4, and cancel this number 4. So the remaining is 8 times 7 times 6 times 5 equals 1,680. So that is the answer. There are 1,680 ways to arrange the letters in the word lollipop.